Here we are going to discuss about string editing. String editing or edit distance, which is an application of dynamic programming. So the string editing is used to find minimum number of transformations required to convert one string to another string. So one string to another string, here we are going to convert. So while converting one string to another string, uh, operations are insert, delete, and substitute, and these are the three operations which cost is 1. And another operation is copy character. Copy character means if two strings, the character in the two strings are equal, then the operation is said to be same character or copy character. It requires 0 cost. So the time complexity of string editing is order of m by n. Order of m by n. Suppose here one example, a is equal to, we will take it as cat, and b is equal to cars. So here edit distance in between a to b. Edit distance in between a to b is equal to 2. Why? Because here we need to make replace t. Here t is replaced by r. So here t is replaced by r. So see, t is replaced by r. Here the cost is 1 for the replacement or substitution. And s, here s is not here. That's why s is inserted. This cost is 1. So total cost of edit distance of a to b is equal to 2. Okay. So this is the edit distance operation. Okay. So here we are going to take one more example and solve step by step with the help of dynamic programming technique. So here string 1 is equal to A, B, C, E, G, and string 2 is equal to A, B, C, F, G. Here the problem is convert string 1 as string 2. So here this is the problem. So first we need to construct a table. So this is a table. Here first one is null. Here also null is there. Here we are going to convert this ADCEG to ABCFG. So this is a table. So A, D, C, E, and G. This is a string 1. We are going to convert this string 1 into A, B, C, F, and G. A, B, C, F, G. So this is the table. Here we are going to fill row by row. This is the table here. Here first we are going to fill the first row. So this string is converted into this form. That's why this null character is changed as null. So here no more transformations are required because this is equal to this one. So next one, this null is changed to A. That's why it requires one insertion. So insertion cost is 1. Same way this null is converted into, both of these two are considered to fill here. So null is changed to AB. That's why 2 insertions it required. That is 2. Null is converted into ABC. 3 insertions are required. Null is converted into ABCF. 4 insertions are required. Null is converted into ABCFG. 5 insertions are required. Okay. Same way second row here we are going to change. A is changed as null. That's why one deletion is required. The deletion operation cost is 1. So A is converted into A. No more operations are required. Same way A is converted into AB. AB. So it requires one insertion. A is converted into ABC. It requires 2 insertions. Same way here 3 and 4. Same way D is converted into null. One deletion is there. Sorry, AD. AD. AD is converted into null. 2 deletions are there. AD is converted into A. It requires one deletion. And AD is converted into AB. AD is converted into AB. So here one substitution. So AD is converted into AB. This is the same character. That's why no cost for that operation. And D is converted into B. Here substitution operation is there. That's why the cost is 1. Same way AD is converted into ABC. A to A, no more operations, and D is substituted as B. It requires 1 and C is inserted. So that's why here 2 is there. Same way 3 and 4. So here ADC. ADC is converted into the null. That's why 3 deletions are required. Here 3 deletions are required. ADC is converted into AB. Sorry, ADC is converted into A. 2 deletions are required. After that, ADC is converted into AB. ADC is converted into AB. How many operations are required? 2. Why? Because ADC is converted into AB. So it requires no more operations and it requires substitution and it is insertion. So 2 operations are there here. After that, then ADC is converted into ABC. So here the cost is 0 and this is a substitution operation, cost is 1. This cost is 0. So here 1 is there. After that, ADC is converted into ABCF. ADC is converted into ABCF. It requires 1 substitution and 1 insertion. So the cost is 2. After that, ADC is converted into ABCFG. ADC is converted into ABCFG. So here no cost and this is one substitution, and C, no cost. These two are the insertions. So total cost is 3. Okay. Same way ADCE is changed into null. It requires 4 deletions. ADC is converted into A. It requires 3 deletions. ADCE is converted into AB. It requires 1 substitution and 2 deletions. That's why 3. ADCE is converted into ABC. It requires 1 substitution and 1 deletion. ADCE is converted into ABCF. It requires 2 substitutions. ADCE converted into ABCFG. It requires 2 substitutions and 1 insertion. So cost is 3. Same way ADCEG is converted into the null. 5 deletions are required. So ADCEG is converted into A, 4 deletions are required. ADCEG is converted into AB. 1 substitution and 3 deletions. That's why 4. After that, ADCEG is converted into ABC. It requires 1 substitution and 2 deletions. And ADCEG is converted into ABCFG. It requires 2 substitutions and 1 deletion. After that, ABCEG is converted into ADCEG is converted into ABCFG. So here cost is 0. D is substituted with B. Cost is 1. And here C. This is also C. That's why the cost is 0. After that, E is substituted as F. 1 is there. And here G. Here also G. So cost is 0. So total cost is equal to 2. So here the minimum number of transformations required to convert this string 1 into this string 2, the cost is 2. So here 2 operations are obtained by backtracking from the answer node as follows. So here what are those 2 operations? Here 2 operations we are going to use. One, E is substituted with F, and E is substituted with F. This is one operation. Another one is D is substituted with B. All of these 2 are shown here. So here start with answer node and move towards by taking diagonal values. So here G and G. So there is no transformation. That's why here total number of operations is equal to 0. In first step, here G and G. It requires 0 operations. Why? Because here is also G, here also G. There is no conversions are there. And after that, move diagonally. So it is. So here EG is converted into FG. Here EG is converted into FG. So here total operations are 0 plus 1, that is equal to 1 is there. After that, CEG, here this is 1. CEG is converted into CFG. CFG. So which requires 1 substitution operation, and which is already performed in this previous step. So this step requires 0 transformations. That's why total number of operations are 1. After that, DCEG. This is 1. DCEG converted into BCFG, which requires two operations, two substitution operations, and one is performed in the previous step and another one here we are going to add, that is one, these two. And ADCFG is converted into ABCFG. It requires two substitution operations. So all these two substitution operations are performed in step 2 and step 4 respectively. So here the required operations are 0. So total number of operations required to convert ADCEG to ABCFG is equal to 2 here itself. So this is the problem of string addition.